Hello, students. Your teacher here, Mr. Sarasinski, with another episode of Algebra 1. This is lesson 8.12, solving quadratic equations, choosing the best method. Man, and we've spent a lot of time on finding the roots of a quadratic, and you think this stuff's important. By God, we have, 5 different ways to do it. And so here there's 4, but there's a bunch of factoring methods, and you can tell that finding the roots is important. Okay, there wouldn't be this many techniques if it wasn't. So let's get started. Boom shakalaka. Factoring best used when the equation is factorable. Okay, that means there are factors of C that add to equal B. Okay. Best used square root method when there is no bx term. When there's no middle term. Okay. Completing the square we are not going to do. Okay, you may do that in Algebra 2, but right now I'm not concerned with you knowing how to do that. Quadratic formula. You can use this for all other cases. Okay, the quadratic formula always works. Okay, it always works. That's what's so great about it. Okay, it always works. So when is a quadratic equation in standard form factorable? And it is factorable when the equation is factorable if its discriminant that is d equals b squared minus 4ac is a perfect square. Okay, so like 1, 4, 9, 16. Okay, but I think it's easier to think about something as factorable if you have factors of C that add up to equal B. All right, so number 1, choose a method and solve each equation below. You can only use each method once. All right, so number 1, let's go ahead and get it in standard form. Subtract 73. X squared minus 6x minus 66 equals 0. All right, so for this equation, factors of 66 that add up to equal 6. Let's see, 66 and 1, 33 and 2, 11 and 6. None of these will add up to equal 6. So 22 and 3 is one that I left off of there. Let's go ahead and just use the quadratic formula. Okay. A is 1, B is negative 6, C is negative 66. So X equals negative 6. Actually, I'm going to erase this real quick because I'm going to run out of room. The quadratic formula takes up so much space. Plus or minus the square root of negative 6 squared minus 4 times 1 times 66. All over 2 times 1. This is the quadratic formula. If you don't know it, you need to remember it. And there's a lot of good songs to help you remember it if you Google. There's one, Google search quadratic formula song and dance. And there's a lady, she's got a white shirt on and a long necklace, and she does this song and dance, and it's hilarious. You guys will love it. Check that out. So let's simplify the discriminant first. Okay, 6 squared, negative 6 squared is 36. Negative 4 times 1 is negative 4. Negative 4 times 66 is negative 264. Okay. So 36. Oh, this should be plus 264 because this should be a negative 66. Sorry about that, guys. So x equals negative and a negative make a positive 6 plus or minus the square root of 36 plus 64, which is 300, all over 2. Now we can simplify the square root of 300. Okay, that is the square root of 100 times the square root of 3. And the square root of 100 is 10. So that's 10 square root of 3. So x equals 6 plus or minus 10 times the square root of 3 divided by 2. And 2 goes into 6 3 times. So x equals 3 plus or minus 10 divided by 2 is 5 square root of 3. And this is our answer. This is as good as we're going to get for the roots. So it's 3 plus 5 times the square root of 3, 3 minus 5 times the square root of 3. And it's going to be an irrational answer, so there's no point to simplify it any further. Okay, that's good. All right, number 2, no bx term. This should be square root. Let me switch colors. Going to add 4 to both sides. 9x squared equals 4. Got to divide by 9 because we're trying to isolate the x squared term. X squared equals 4 divided by 9. Don't have to simplify it. Just leave it like that. Take the square root of each side. X equals plus or minus 2/3. Because the square root of 4 is 2 and the square root of 9 is 3. And so we'll write this as a solution set that is negative 2/3, positive 2/3. Okay, moving on. Let's not waste any time here. Number 3, subtract 3 from both sides. 2x squared plus 8x plus 7 equals 0. And as I look at these, I think this is going to be factoring, okay? Let me see. I could do slip and slide. So a is greater than 1, okay? And I'm doing it a little different than I could also do, just so you guys know, I could also do the quadratic formula, and that always works, okay? So factoring, let's slip and multiply. No. Let's not do factoring. Why is that? Okay, so I noticed really quickly as I started to slip and multiply, this was going to give me 14. And there are no factors of 14 that add up to equal 8. There's only 14 and 1 and 7 and 2. Neither one of those will give me 8. So I noticed that I cannot factor this, okay? I have to do the quadratic formula. So we're going to do that again. A equals 2, B equals 8, C equals 7. So x equals negative b, negative 8, plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So let's simplify the discriminant first. Okay, 8 squared is 64. Negative 4 times 2 is negative 8. Negative 8 times 7 is negative 56. So that leaves me with 8. All right, so x equals negative 8 plus or minus the square root of 8 all over 4. All right. Well, we can simplify the square root of 8. So the square root of 8 over here. Let's do this. Square root of 8 can be broken up into the square root of 4 times the square root of 2, right? This is the largest perfect square factor of 8. And that's how you simplify radicals, okay? If it's not a perfect square, then you try to find the largest perfect square factor, and then you split it up, Okay, and then we can take the square root of 4, which is 2, so it's 2 times the square root of 2. All right, so that's going to come back over here. I'm going to rewrite this as x equals negative 8 plus or minus 2 times the square root of 2 divided by 4. Okay, so this simplifies to x equals negative 4 plus or minus square root of 2 divided by 2. And this plus or minus, and we can't really simplify it any more than that. Okay, that's all right. Number 4. Gosh, getting a lot of irrational answers here. No big deal. We need to get comfortable with those. Number 4, factors of 14 that add up to equal 9. Yes, this is my factoring example. So, factors of 14, 14 and 1, 7 and 2. 7 and 2 will add up to give me 9. So I have x plus 7, x plus 2 equals 0. And this is, so you guys know, this is what we call factored form. Okay. And then to solve, we just set each one equal to 0 and solve for x. Subtract 7, x equals negative 7. Subtract 2, x equals negative 2. And maybe you are a person who notices that the answer is just the opposite sign of what's inside the factored form, okay? And if you're a person who notices that, then I'm totally fine with you going from there to here, okay? Use your big brain, work hard, and smart, okay? So x equals negative 7, negative 2. Always write your answers least to greatest. All right, next page. Solve each equation below using your method of choice. Simplify all irrational solutions. All right, so here we go. Number 5, subtract 4 from both sides. Okay, so we can get it equal to 0. And x squared minus 2x minus 4. Man, I'm getting all jumbled up here. Let's do this. X squared minus 2x minus 4 equals 0. There we go. Now, what are the factors of 4 that will add up to give me 2? Ooh, there's not any, so I can't factor this. If I can't factor, I'm going to do quadratic formula. A equals 1, B equals negative 2, C equals negative 4. So x equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2a. Oops, a is 1. Simplify the discriminant first. So negative 4 times 1 is negative 4. Negative 4 times negative 4 is positive 16. So that's going to simplify to 20. So x equals negative and a negative make a positive 2 plus or minus the square root of 20 over 2. Square root of negative 20 will simplify. We can say the square root of 4 times the square root of 5. Square root of 4 is the largest perfect square factor of 20. And if we take the square root of 4, that leaves us with 2 times the square root of 5. So that's going to come back over here. And I can write it as x equals 2 plus or minus 2 times the square root of 5 divided by 2. And these are all going to cancel out. And I'm left with x equals 1 plus or minus the square root of 5. Okay, so it's 1 plus the square root of 5, 1 minus the square root of 5. And that's a irrational solution, so I can just leave it like that. Okay. Number 6. Number 6, a is greater than 1. So I'm going to try slip and slide. Let's multiply by 10. x squared. Oops, I'm doing the wrong color. Kind of picky about my colors, y'all. I can leave that. But I'll multiply by 10. X squared plus x minus 20 equals 0. So I need factors of 20 that add up to equal 1. 20 and 1, 10 and 2, 5 and 4. So that'll be x plus 5, since b is positive 1. And x minus 4 equals 0. And since I multiplied at the beginning when I slipped, now I need to slide and divide. Got to undo that multiplication. And so this will reduce to 1/2. This will reduce to 2/5. And if there's a number left in the denominator, that slides a little bit further in front of the variable. So my factored form is 2x plus 1 times 5x minus 2. Okay. Draw your dotted line, set each one equal to 0. Add 2, subtract 1. 2x equals -1. 5x equals 2. And then divide by 2. Divide by 5. X equals -1/2, 2/5. All right, number 7. All right, in number 7, I noticed really quickly, this is slip and slide. I noticed really quickly that each number is either 5 or either has a 5 or ends in 0. And so that is a clue that there's a GCF. Okay. So I'm going to take out a 5. There's not a variable in each term, so all I can take out is 5. And if I do that and divide each term by 5, I'm left with x squared minus 3x minus 10 equals 0. Okay, now what I have left inside parentheses here is where a is equal to 1, I can factor. Okay, and so factors of 10, 10 and 1, 5 and 2, I can use 5 and 2. So I'm just going to bring down my 5. And then since the b term is negative, I know the larger factor needs to be negative. So x minus 5, x plus 2 equals 0. Now draw your line, set each one equal to 0. And you can just kind of forget about that 5. Add 5. Okay, not really sure what happened there. Let's keep going. So, add 2, and x equals 2, x equals 5. Write your answer as a solution set, least to greatest. Good to go. All right, number 9. This is going to be the last example I do in the notes. Okay, or number 8 here. Okay. So we need to get everything on one side. Subtract 9x. 36x squared minus 9x equals 0. And there's no c term. Okay, so if there's no c, this is a clue to factor as the GCF. So I know that there's a variable in each term, so I can take out an x. And I also noticed that 36 and 9 have a common factor of 9. So if I take out a 9x, and then I divide each one of my terms by 9x to see what's left over, I'm left with 4x minus 1 equals 0. Okay. Set each factor equal to 0. Solve for x. Divide by 9. X equals 0. Add 1. Divide by 4. X equals 1/4. So x equals 0, 1/4. All right, so you've gotten to see a little bit of everything. Hold on, let me double check. Let's do we're gonna do number 11. Okay, the next one is, so 9 is factoring, 10 is, this is factoring. Okay, slip and slide if you wanna do it. 10 is quadratic formula. Number 11, this is square root, okay? Subtract 32, get everything on one side. 0 equals 6x squared minus 48. I'm sorry, I'm not doing this right. It's Friday, y'all. All right, add 16. Right, so when we're trying to take the square root, trying to get the variable by itself, okay? Divide by 6. X squared equals 48 divided by 6, which is 8. Take the square root of each side, and x equals plus or minus the square root of 8. Well, the square root of 8 can be simplified. We've already done this once. The square root of 4 times the square root of 2. Square root of 4 is 2 times the square root of 2. So I can bring that back over here. X equals plus or minus 2 times the square root of 2. That's your answer. I'm your teacher. This is the way.